Welcome to Prof.Ahilaa Max, Plus 2 Mathematics, Tamil Nadu State Board Syllabus, Chapter 1, Application of Matrices and Determinants, Video 1.16, Example 1.15 and 1.16. Dear children, let us recall few points now. Definition of rank of a matrix row of A. The rank of a matrix A is the order of a highest order non-vanishing minor of the matrix A. Suppose the order of A is 3 by 3, then rank of A is less than or equal to 3. Suppose it is 3 by 4, then rank of A is less than or equal to minimum of 3 and 4, that is 3. We follow the following steps to get the rank. Step 1. Check for at least one non-vanishing minor of order 3. If it exists, then rank of A is 3. If all vanish, go to step 2. Step 2 is check for at least one non-vanishing minor of order 2. If it exists, then rank is 2. Suppose all vanish, then go to step 3. Then we can confirmly say that rank is 1 because only for 0 matrix rank is 0. If there is at least one non-zero element in the matrix, then we can say rank is 1. Okay? Keeping the points in mind, example 1.15, find the rank of each of the following matrices. First matrix, a 3 by 3 matrix, 3 2 5, 1 1 2, 3 3 3. Let us consider it as A. Now we check by the step 1. We find the minor of order 3. Here it is only 1. So we get the determinant value of the given matrix, which we get as 0. So that the minor of order 3 vanishes. Therefore, we can say rank of A not equal to 3. So, we proceed to step 2. For step 2, we need to check all 2 by 2 minors of A. So, collect all 2 by 2 minors of A. So, using row 1 and 2, we get these 3 minors. Similarly, using row 2 and 3, we get these, and rows 1 and 3 we get these minors, and the column elements we get this one. So thus we are getting 10 minors. Okay, out of these 10 minors, if we find any one not equal to 0, then we can say rank is 2. If we consider the first minor itself, so minor of order 2, if we consider the first one, that is 3 2 1 1, it itself gives 1 which is not equal to 0. Therefore, we are able to identify at least one non-vanishing minor of order 2. Therefore, rank of A equal to 2. Understood? Fine. The next problem in example 1.15 is a 3 by 4 matrix is given 4 3 1 minus 2 minus 3 minus 1 minus 2 4 6 7 minus 1 2. Let us consider it as A. Now as usual, you check for minors of order 3. So what are the minors of order 3 here? By deleting C4 we get this one. Similarly, deleting C3, column 2 and column 1, will be getting 4 such minors. Okay. So when you find the determinant value of these 4 minors, we find that all minors of order 3 vanishes. Okay. Therefore, row of A not equal to 3. Then we move to step 2. We need to check for at least one non-vanishing minor of order 2. So when we see here, the first 2 by 2 minor itself is non-vanishing. See, minor of order 2, it is enough to identify at least one. Okay. So 4 3 minus 3 minus 1, the value is 5, which is not equal to 0. Therefore, row of A equal to 2. Please remember, it is enough to identify at least one non-vanishing minor. Let us see a remark. Finding the rank of a matrix, there are two methods. First one is by definition method. Searching a highest order non-vanishing minor is quite tedious when the order of the matrix is quite large. Okay, it is a difficult method. Method 2 is by reducing to row-echelon form. So reducing to row-echelon form is easy one. How we find the rank means step 1, first reduce the given matrix to its corresponding equivalent row-echelon form. Step 2, the number of non-zero rows equal to rank of the matrix. Okay. So very simple, you need to reduce to row-echelon form, then count the number of non-zero rows which will give the rank of the matrix. Got it? This is the easy method. Method 2 is easy one. Example 1.16. Find the rank of the following matrices which are in row-echelon form. I hope you know what is row-echelon form. First problem, it's a 3 by 3 matrix. 2 0 minus 7 0 3 1 0 0 1. Now check whether it is in row-echelon form. So from the bottom and from the left, the elements should be 0. It should match the upper triangular matrix form. So it is row-echelon form. Now count the number of non-zero rows. First row is non-zero, second row is also non-zero, third row is also non-zero because 1 is non-zero. So 1, 2, 3. There are 3 non-zero rows. Therefore, number of non-zero rows equal to 3. Therefore, rank is 3. Understood? Second problem, it is also a 3 by 3 matrix. Here, the last row is a 0 row. And you can confirm that the given matrix is in row-echelon form. So, we count the number of non-zero rows. First and second rows are non-zero, but the third row is completely 0 elements. So, it is 0 row. So, number of non-zero rows equal to 2. Therefore, rank is 2. Now, the third problem. This is a matrix of order 4 by 3. So, first check for echelon form. So, it is of row-echelon form very clearly. The A12 element and A23 elements are also 0, but we don't want to worry about that. We need to check from the bottom and from the left, the elements should be 0 and the matrix should match upper triangular matrix form. So, it is of a row-echelon form clearly. Now, count the number of non-zero rows. First row is non-zero and second row is also non-zero because 2 is non-zero value, and third and fourth are 0 rows. So, how many number of non-zero rows? Only 2. Therefore, rank is 2. Understood? Fine. Video 1.17 contents are theorems 1.11 and 1.12. Example 1.17 and 1.18. Stay tuned. Success is ours. Thank you, my dear children.